right, it looks like we have a good group already joining, and it's great. Today we have two senior leaders from PayPal in the class. I'm sure all of you know about PayPal, global online payment system with many subsidiaries, including Venmo. They've definitely been a leader in addressing fraud since the very beginning. I've heard different statistics, and maybe they can share the latest. I've heard something like 0.3% of revenue in fraud versus over 1% on average in the US at least. So they've done a great job in the fraud area. And it's been a pleasure working with PayPal, collaborating with ICME for a number of years now. Most recently, we've worked together to establish the PayPal Scholars, which supports PhD students and their research in ICME. So today we'll hear about how PayPal is using machine learning and deep learning, advanced techniques to address fraud and for credit risk assessment. And I'd love to welcome Janice Say. She's the Senior Director of Data Science at PayPal. She's been at PayPal for a number of years now and was previously at eBay. She has a master's from Stanford and in the CS department, so has been in many of your shoes a while ago. And we also have today Vijay Navare. He is now leading the AI research team at PayPal and hails from Cornell, where he has a PhD in EE. And so welcome to you both. And I'll just say to all the students, please feel free to enter your questions in chat throughout the talk. I think we'll stop somewhere midway and answer questions. And so just keep throwing those questions in chat, and hopefully we can have a lively discussion, maybe midpoint and then at the end as well. Okay, and thank you, Janice and Vijay, for coming today.
Thank you, Karen.
Yeah,
Thank you for the introduction.
Yeah.
Yep, as Karen mentioned, today we'll be sharing with you on AI in PayPal and also the emerging trends in this space. So the first half will be covered by me to go over the AI efforts in PayPal with a special attention on the fraud detection. And after that, we'll go through more general emerging fraud trends. Thank you. Yep, I've been with, as Karen mentioned, I've been with eBay and PayPal together 15 years. Before that, I graduated from Stanford CS department. And since then, when I joined the company, I've been focusing mostly on AI data science, from fraud detection, risk management, and also other domains like customer service enhancement as well. So I'll share more with you what we have done here at PayPal to building this data science and machine learning system. Next slide, please, Vidhu. First of all, a brief overview of PayPal. PayPal is a leading company in the digital payment. The company was launched in 1999, and today we have over 360 million active accounts over the world. We cover more than 200 markets globally, and we have 23,000 employees worldwide. The brands under PayPal include Venmo, Zoom, Braintree, iSettle, Honey, GoPay, just to name a few. And together is an overall ecosystem where we provide solutions through all these different brands. And then also we have different data science solutions to support these different businesses as well. And I will introduce you the PayPal ecosystem so you will get to know our business better and also what type of challenges that we have over here. And also that will help you to understand why we have such a data science solution system. Next slide, please. Our platform is a two-sided platform with both buyers and sellers. On the buyer side, we are providing products and solutions to help people make payments to move money effectively, as well as providing financial help like credit services to the consumers. And for sellers, the platform is providing online and in-store checkout solutions so that it will help them to support their e-commerce site and all their services. And also we provide various tools like robust fraud management to help them minimize their loss and a lot of user insights as well that can help the merchants to attract new customers, to cater to the portfolio, like which customers they can get more to the business, as well as also credit services to help their business grow. Because for merchants, they need a lot of capital and they need this type of credit support so that they can continue to expand their business over time. So this is overall the PayPal business. And there are some unique challenges with this ecosystem. Next slide, please, Vidut. Here you can see the amount of data that we're handling. First line over here is amount of accounts. Again, we have over 360 million active accounts on the platform. And that translates to a lot of different events and a lot of unique entities. So the event is everything the users that conduct on our platform, from logging in, checking out, signing up for a new account, changing profiles. So there's a lot of things that they do on the platform. All these translate into events. And with so many active customers and also so many things that they do on the site, we have over 75 billion events per year. And a lot of entities as well. Because they will be, some of these will be, we'll get the IP address, we'll get the email information. There's a lot of this information that we collect about the users. So about these accounts, there's a lot of different entity information. Besides device, there's also financial instruments like the card, bank information. So all this information that we collect about these users so that we can know better about these people and also know more about them, the risk, and also what type of information we can collect to help them to conduct their business better. We have a lot of payment attempts every year, 21 billion plus per year. The volume has been growing year over year. Probably have heard from our financial report. Every year we're going 20% plus. So that's reflecting this number. The latest is 21 billion plus payment attempts per year. Overall, it's just a lot of data that we're handling. You can imagine what our platform is needed to handle all this massive amount of data. To provide the best data science solutions, we have hundreds of models running in production. Here you can see some of these numbers over here, and this is only focused on the risk and fraud models. So when we look at other types of solutions, which I will provide more information later, actually it's even more models beyond that. So just on the fraud and risk alone, we have 400 plus models in place, and many of them are computed in real time. 130 plus is computed in real time in a really fast manner in less than 300 milliseconds. And we have a lot of rules as well. So besides models, we need something to be very agile, adaptive. So we have many rules as well. And coming down at the bottom, you can see the platform capability that's needed to support all of these hundreds of models and also all this volume of data. Is about 3 petabytes of total data we're handling. And we have the in-memory data store to store all this information. For example, to look at the velocity, to look at the historical data, we do a lot of computation offline. To store all this for all these 360 million active accounts, it requires a lot of data. So the approximate amount of data is 800 terabytes that we're looking at. Throughout the life cycle, 83 different decision checkpoints throughout the life cycle, and a lot of events being computed a day. Just overall, you can see is a massive system that we're building here to support all the different decisions. All this, I'll go into more details on what we're building behind those hundreds of models, and also how we're enabling such fast system to make decisions within milliseconds for each activity that users are conducting on the site. Next slide, please. Overall, we, as I mentioned earlier, we leverage data science to tackle various business problems. While today's talk is focused on fraud, we use it actually to tackle all the different types of problems, from fraud to marketing to customer service. There's a variety of problems that data science can help. With this focus on fraud, I will share more details on what's the nature of the problem, what is really about risk management, what's the problems that we're talking about here, and also how are the data science solutions being built to address them? How does it translate into the hundreds of models and also all those data points? Next slide, please. For fraud specifically, here you can see more details on the variety of problems that we're looking at. Again, there's a buyer side and a seller side, and some of the problems are common to both sides, while some are unique. Starting at the bottom is the account takeover problem. So this one means unauthorized access to a PayPal account. This is common to both buyers and seller. And why are fraudsters doing that? So with the access to the account, they can exit the money that is currently in the PayPal account, or they can use whatever financial instrument that is currently already registered, like a card or bank. They can use that account to make payment. So it's a way to exit money as well. And of course, for sellers, they have received a lot of money from their customers. So once they take over a seller account, there's a lot of money that they're looking into to exit out the money. So that's the first one over here, account takeover. Second one is about identity. This is about stolen identity or stolen financial for consumers. So for buyers, they may make use of a stolen card they got elsewhere or a stolen bank account they got elsewhere and attach it to a PayPal account. And from there, they can start making payment to monetize all of it. This is a really big problem for from a payment angle. So a lot of banks and also a lot of payment industry, this is one of the top problems for them. And on seller side, stolen identity means they to have a fake identity and also pretend to have a legitimate business, so that like when someone buy from a fake site, then they will be the seller will be able to monetize all of it. So that's the identity problem on the seller side. After identity is abuse problem. These are not necessarily using stolen financial, but they are looking at what are the loopholes of like the PayPal protection policy, what are the loopholes of the products. Overall, PayPal has a very good and solid buyer and seller protection policy in place, so that we make sure that we provide the best experience for our customers. But at the same time, it means the customers, they might sometimes abuse it. And the way they abuse, maybe they are filing excessive returns or refunds and filing claims saying they have not received item, but indeed, actually they have received it. So these abusive claims. So those are some examples of abuse. Or it could be collusion. So collusion is the two accounts working together. So the buyer and seller may be actually the same person, or they are like just a group of accounts that they know each other. So from here, they may be filing fake claims. So the buyer may be sending a claim saying have not received item, and seller said has received. So throughout this system, they can manipulate our protection policy to make money out of our system. That's an example of collusion. And there are various, actually, they're very creative. There are many different examples on how they work together to have various types of ways to game the system. So it has been a challenging problem that we tackle all these different ever-changing patterns. Coming to the last one at the top is moving to the credit side. Here is on the seller front is about potential bankruptcy. So sometimes sellers, they might not be able to maintain their business because of various problems. And this will become a liability to PayPal because the sellers might not be fulfilling their transactions. And sometimes the seller might take all the money away. So all of this will generate a loss to PayPal or to the customer. So there's something we need to manage. And on the consumer side is about bank payments, because users can use their bank to make payments. So sometimes the check may be bounced. So we could get all these temporary credit problems. So it's a risk that we need to manage as well. Here is is laying out the majority, the most common problems. And we have a variety of other problems as well, like money laundering, etc. And for those, I will share more details later on. Next, we'll share more with you on how those stolen identity look like. For stolen card, there's a huge market out there. There's a lot of professional fraud. There's a lot of underground markets. So here is some examples of some data points over here, how easy it might be to get to a stolen card. The top chart over there, you can see the price points for some stolen card numbers. So you can see it's not expensive. It's like under $10, you can get a stolen card. And other credentials out there. So it's not very expensive. And also there's a huge network out there. And on the other table, on the right-hand side, is about hacking into email. This become more expensive because once you get hacked into email, there's a lot more information that the fraudster can get a hold to. And it's also sometimes potentially harder to get into email. But still, there's an underground market for it. And this one especially would be very useful in social engineering and other types of malware as well, once a email is being attacked. We are constantly monitoring all these underground markets. And one of our efforts is also trying to do this reverse engineering, or like try to see what the tools being offered in the underground market, so that we can know the ecosystem better as well, and we become better, more prepared. But with this, it gives you an idea of why it's a constant problem for PayPal, because they're just such a massive network out there with all this information being exchanged. Next slide, please. For us, how do we tackle it? There are three major pillars that we're adopting in our system. First, maybe machine learning might be the first thing that comes to mind. Machine learning is so powerful. We can put all the data into the machine learning, let the algorithm figure it out. But over time, we have seen that just machine learning alone is not sufficient. And we see that there are these three pillars beyond just machine learning. First is a human approach to the problem, the business understanding, and story-based analytics. So that's the first pillar. Second one is a end-to-end customized management system supported by advanced machine learning algorithm. And the third is the team behind it. We need to have the right people behind this. So it's not just about technology, but having the right team in place. Those are the three pillars that we're looking at, and I'll provide more details on each of those. First one is on the story-based approach. Here you can see some what it means when I say story-based approach. Vito, if you can keep sharing, please. Yeah. Here is a very basic example. Is one of the more simple fraud that we're looking at. For us to understand our problems is we need to know our data. We need to know what we're trying to address. So the business understanding of it is very important. Knowing what problem we are trying to address, that's the very first thing before we get started with any solution. And we start looking at the data to really understand the patterns. So look at this one. For example, Sam is a PayPal customer. From the profile information, is a New York resident, and usually the transaction is based out of New York. But also then we have a transaction coming from this account is at 2 a.m. and also it's an IP address from somewhere else, another country, Thailand. So what's going on? If we don't know the data enough, probably is we will assume very likely is account takeover, because from just statistics wise, this is most common scenario. But if we look deeper, if we look for other indicators, you might see that there could be a business trip happening. It could be a vacation. So we look at maybe what device is coming from, and also the connecting accounts. Is it what is happening? All the different transactions, what is that person buying? So look at all this information to look for other potential scenarios as well. So from here, we actually find that it's not account takeover, but it's indeed Sam using the account, but just is that he is traveling. So this is about understanding data, understanding business to know what's going on so that we can build the right features. Feature engineering is still a very important, even today's world with deep learning, it continues to be a important capability, important ingredient in the whole formula. And also it allows us to structure the solution properly. Without knowing what we're trying to answer, sometimes we might just blindly try a supervised problem. But if we know the problem, then we will have a better idea of, is it a supervised problem, unsupervised problem? Are we trying to just look at fraud probability ranking, or actually we're looking at how to focusing on the good users and provide the best experience for them? So all these have different optimization function or objective. And without truly understanding what we're trying to tackle, sometimes we build maybe the best machine learning algorithm for a particular data set, but it's not answering the question that we need. And it's not even the data points that we need to fit it to. So that's the first pillar that is very important beyond the technique, but really understand the data and understand the business problem. Yeah. After knowing the data, the business problem with the story-based analytics, then of course, algorithm is next is about advanced algorithms. We still need to continue to evolve our algorithms. As we all know, this space is constantly evolving. We went from logistic regression many years ago to neural network, GPT, deep learning, all becoming more capable and able to process more data. So next is definitely about advanced algorithms. But at the same time, we need a very highly customized end-to-end platform to make sure that the algorithms and the data are really working to the best they can. And the next slide, you can see at a high level, the illustration of our platform. Here is a very high level illustration of how our end-to-end platform looks like. The blue part is the algorithm. So we have both in-house and open source modeling platforms, H2O, TensorFlow, and in-house Shifu. So those are able to execute the different machine learning algorithms. And beyond that is about, we have a feature repository. So after all those feature engineering, we have many features that can be fed to this system very quickly. And also we have a very robust simulation as well, because not everything can be, we can get live data. We need to simulate historically how they behave like. So simulation is very important as well. So with all this, we build hundreds of models very quickly and push it to life into the real-time system and let the real-time decisioning system to run this model within milliseconds so that we can make a real-time decision for all the activities that go through the platform, whether they're logging into the site or making a payment, any activities, everything is about, we do mostly real-time decisioning. And that is not the only picture, but very importantly is the bottom line over here is the real-time feedback loop. We are constantly looking at what are the signals from the real-time decisioning. Is it a right signal, wrong, right decision, wrong decision? How is the customer reacting to it? Then we pick up all these signals so that we can quickly adjust our solutions with the latest data points and the latest signal. So this is a loop that is constantly running, and we can push out a new solution within days based on the latest signals. So this is the second pillar that I mentioned earlier. We need a end-to-end platform with advanced algorithms sitting in it, as well as all the data and feeding to our real-time decisioning system so that we can react to any latest problems very quickly. Here is just a little bit more information on the deep learning. So we're very excited that we're able to push out deep learning more than 2 years ago to the fraud problem. In the industry, it has been mostly image processing and NLP problems, but it's we're able to be one of the first companies to apply deep learning to the fraud problem. And this has proven to be successful. We're able to push the effectiveness of our solutions by more than 20% of effectiveness. And we have different types of deep learning being applied in production. Next slide, please. Yep. And a bit beyond risk, I mentioned earlier, beyond risk, we also tackle many different problems. So risk is just one of them. And this is just some other examples of beyond risk. For example, whether we offer credit, marketing, like what campaigns, which customers to target, sales, how do we do cross-sell of different services, products. Compliance is about anti-money laundering or any other regulation compliance. All those things we leverage data science, and also customer service. How do we know what is the intent before they call so that we can provide the best service? And besides supervised modeling, we have a number of different types of techniques like real-time graph, active learning, explainable AI, explain why are we taking certain actions. So all those are very important. So here are just a very high level, some examples beyond risk and also beyond supervised modeling. And coming to the last one is about the third pillar. We have the techniques, we have the data, we have this analytics, but we need, what is very important is the right team behind it. Over the years, we have learned to build a successful team, we need a diverse background. From a skill set perspective, these are the 5 primary skills we're looking at: machine learning, analytics, problem solving, engineering, and statistics. And it ties very well to the other 2 pillars on we need to be able to build the best platform, having very advanced algorithm, knowing how to build and use advanced algorithm, as well as analyzing the problem. So all these skills are tied to the first 2 pillars. And with that is, besides the skill diversity, also we're looking at other types of diversity as well. Like for example, experience from the industry, or they are completely new, they just graduated, so they have the latest academic background. So this experience versus the latest from academia both are important. And also coming from quite different discipline, they don't necessarily have to be all just from one degree, but or not just all coming from, let's say, technology industry. So people coming from different industry, they have a different perspective that will help broaden the perspective and mindset of the team as well. So with this, overall, the team can complement each other, where they overall have this basic foundation around these 5 areas, while some of them will master in 1 or 2 domains. So everyone is a T-shape, and they are able to T-shape in a skill set where they master in 1 or 2 areas while having the basic foundation, and then each one bring in different perspective. So that build a strong team to complement each other. And you can see the bottom here pointing out some of the mistakes that have been experienced over time. If we were hiring just a single skill set, or we just overinvest in a single area, let's say just machine learning platform, or just purely machine learning skill set, this one over time might not be able to give us the most well-rounded system. So we're looking for people and also the overall team to be able to complement each other and be able to build this end-to-end ecosystem. So here are some experience and also what we learned over time. With this, all these 3 pillars, everything, we have been able to give very successful AI solutions and able to tackle all the different problems that we have. And we look forward to continue to enhance our AI solutions in PayPal. And in the next half an hour, you can hear from Vidhu on what are the emerging AI technologies and how we're going to evolve over time to able to keep up with the rest of the industry and also the fraudsters as well.
Thanks, Janice.
Thank you.
Hey, Karen?
Yeah, shall we open up to a few questions now?
Yeah, I think that'll be a good idea. Yeah.
And I can kick off if you want. I was interested, you mentioned, Janice, the explainable AI. Can you share a little bit more about how you are using explainable AI or some of the challenges that you see in this kind of new approaches to really being able to explain what's in the deep learning model?
Yep. Yeah, with the nonlinear algorithms, has been getting very difficult to kind of understand what's going on. So we have been investing in different techniques to get a better understanding of like kind of estimate why the algorithm is making certain decisions. And the usage of it is to explain to the user sometimes, or internally, actually for internal customer support, for example. So let's say someone's payment got declined. What's the reason behind it? So depending on the reason, we might want to have a different approach to it. So it could be that, oh, the card looks very new, or it could be, oh, the address doesn't look, the address is not correct. We cannot find it on the map, or the address, the shipping address doesn't match the primary residence. So depending on reasons, it can help tailor our customer support on what should be the action with the user. Should we reach out to the user? Should we just decline it completely? Or someone, when the customer calls, what are the information we can provide the customer to remedy the situation, so that the next time when the customer comes back, doesn't need to run into the same situation, in case that is not a fraudster, but a good account. So that's one example of the usage. And in terms of technique, there is a variety of things that we're experimenting. I think it's also touched on in Vidu's talk, so we'll share more some of those algorithms later on. Yeah.
Excellent.
Karen, I have a quick question. Can I?
Sure.
You mentioned at some point that there are hundreds of algorithms to address fraud and other aspects of your business. I was wondering, is that because you need to address many different situations, many different circumstances, or is because none of the algorithm is really truly effective, and so you need some sort of an ensemble to get the answers to have confidence in the answers?
Yep. It's more about hundreds of models, not necessarily algorithms. We are using usually the primary algorithm, like a neural network, GPT, etc. But we need so many models because, like, different problem that I mentioned earlier, for example, whether it's a bounce check versus a stolen identity, the optimization will be different. And we are trying to have a fewer number of models, maybe even a single model to address them, all these different problems, but it is not able to catch all of them as in a as effective manner as having more models. So we have different models to optimize based on the different types of fraud we're tackling. And also sometimes the data points for different countries or different user portfolio, the behavior is different as well. And we have seen it apply different weight to different data points for different portfolio. It allows the solution to be more effective as well. So those are some of the reasons of why we have hundreds of models to address this, the fraud problem.
Thank you.
Any other questions now?
Sure.
Okay, why don't we move into the second part, and maybe we can address more questions at the end.
Sure.
Yep, sounds good. All right, thanks, Janice, for the introduction. I think this sets me up nicely to talk about AI research and in general what we are doing with AI research over at PayPal. As Janice mentioned, fraud, credit, like basically fraud detection, credit risk assessment. These are very important use cases for PayPal, and definitely it's an area of focus for me and my team. But we, as Janice also mentioned, there are other domains also for which we use data science today. And I'll talk a little bit about essentially how we look at the overall situation from a research perspective. So, before I kind of go too far ahead, I want to make a couple of comments. I think when I say AI machine learning here, I think, for this audience, I think I should be very clear. I think we really mean more of the machine learning data science. We are far away from, real artificial general intelligence or anything like that. It's just become like a catch-all phrase. So what I'm really referring to here is machine learning. I like to start on a lighter note. I'll just give everybody a few seconds to read this comic, a short story while we read. So a couple of years ago, maybe it was 3 years ago, I came across this comic, and at the time I remember I had quite a smile on my face when I saw it. Fast forward a few years, and with everything that's gone on, what the world around us, fake news, this, that, and the other. I think you really, the satirical quotient of this comic seems to have gone up over time. And that's certainly the first trend I will start with. Moving on. So here is kind of like a brief agenda, like what I was going to cover in today's talk. The first part will just kind of take a very broad kind of overview of AI machine learning overall in the industry, what is going on. I wanted to summarize a few key trends. This is nothing specific to PayPal here. And then the second part, I will kind of dive a little bit deeper into some of the specific AI machine learning trends that we think are very relevant to PayPal. As Janice said, we are at a unique point in our journey as a company. We are actually privileged to be in a space which is kind of continues to grow over time. So we really need to pay attention to each layer of the stack, if you will, on the AI/ML stack, be it the compute layer, be it the algorithmic layer, also the tools and ecosystems, as well as the application, right? How users interact with the PayPal platform. Each and every dimension here matters. And I plan to talk a little bit about what we are doing in terms of trying to address the trends. One thing here is, again, in the interest of keeping the talk kind of more accessible to a pretty wide audience, I'm not going to get into too much detail here. I've left my email address at the end of the slide decks. Please reach out. I'm happy to have a conversation offline. This is meant to be more of an overview of the different kinds of research initiatives that are underway, in my team. Also have to say that, some of the research that my team does, we work very closely with Janice's team. Like it's a partnership, it's a collaboration at the end of the day. The research that we do eventually feeds into the kind of work that she does, and her team actually takes that work further into production. So with that, let me quickly jump into the kind of broad trends. So just a quick snapshot here. I know this is it's primarily a student audience, so I probably don't need to spend too much time talking to this slide, but still just a quick 1-minute version. All of these kind of, I would say, really path-breaking improvements, be it AlexNet in the computer vision domain, AlphaGo in the sequential decision-making domain, BERT in the natural language processing domain, and AlphaFold most recently last year in the protein folding domain. They've all been kind of like radical shifts in how machine learning and AI has really transformed those underlying domains, right? So you had a certain way in which computer vision was done pre-AlexNet, and then came deep learning and everything changed. It all became convolutional neural nets. With AlphaGo, it's a little bit more of a, what used to be essentially a sequential decision-making problem solved using Markov decision processes and so on. In comes deep learning, out goes everything else. You start beating the world champion, and so on with BERT and AlphaFold, right? The point I want to make here is that we've seen over the last decade, like deep learning really take off and really start to, just 1 minute, I'm trying to move my camera to the right place. This was interfering. Yeah. So yeah, I think what I was trying to say is, yeah, we have now this kind of deep learning, really taking off and disrupting algorithms, domains. Essentially, every problem now has become a deep learning problem. At least, as far as some of the domains here are listed, and this has really happened because of the explosion of devices, data, and compute. that we've been able to achieve through the massive adoption of smartphones, Moore's law and all the kind of kicking in, and basically every 2 years we get twice the compute capability for pretty much the same cost in terms of power and actually literally cost. So while all of this stuff is going on, one of the things that we also wanted to see, or we want to see, is while all of this is happening great, it's in academia, we're seeing a lot of research and a lot of cool, interesting problems being solved. What does it mean for broader industry adoption, right? So I happened to come across this market survey, which was conducted by McKinsey. The survey itself consisted of about 2,400 or so companies. This was sampled globally across different sectors and many different functions within each company and so on. And they tried to kind of like get a status of, okay, where is adoption looking? What is the adoption and what is the impact looking right across different sectors, across different companies and so on. And some pretty interesting insights emerged. I'll spare you the details of the chart on the right. There's too many numbers there. I think just focus on the left. I think here are the 4 things that really kind of stand out, right? So first thing, 50% of all companies now globally use AI in some product and service development or service operations. It's a pretty staggering stat. I mean, it was surprising to me for sure. By the way, these are fiscal year 2019 numbers. So this is pre-COVID. And I'll talk a little bit about what happened post-COVID. There's also the other interesting trend was 22% of all of these companies attributed greater than 5% of their earnings directly to use of AI, right? So it's a pretty healthy number, I would say. If about one fourth of companies are able to make 5% of their earnings. By the way, this is earnings, not revenue. So it's a pretty good number. And here is the most interesting trend: only 16% actually use deep learning in production. So when you sample at a very large scale, adoption of deep learning is actually not quite there. I mean, it's just 1 in every 7 or so companies. So what might be going on? I have my hunches. One of them is I think deep learning. It's not. It takes a certain level of skill and talent pool to be able to put deep learning in production. The other thing is in addition to kind of the skill and the talent, sometimes you don't need to use such a complex model as deep learning to solve a particular business problem, right? So for example, a logistic regression may be perfectly fine to solve a certain class of problems, right? And it might be good enough to meet the business KPIs or business metrics of interest. So I think those are my 2 kind of primary reasons for why I think deep learning is still kind of lagging. Whatever is happening in research is still not yet translating to kind of direct business value. The other kind of surprising stat, this is more of a just surprising stat to me at least, is the most massive kind of year-on-year increase in AI adoption was in the retail and travel sectors for some reason in 2019. I don't have any real insights into why that might be the case, but certainly it's an interesting thing. It's surprising that you would imagine that it's probably going to be bigger in some of the higher tech, or in at least the tech companies and so on. But no, it actually happens to be retail and travel. Finally, financial services. Yeah, PayPal lies somewhere in that box, which I've on that oval which I've highlighted with red. But in general, those numbers seem to be pretty much in line with what I would expect from even where PayPal would be. So moving on to some more impact trends. So the way AI machine learning can really help businesses increase their top lines and bottom lines is either through some kind of automation of certain functions, which typically result in some kind of a cost decrease, or sometimes it's more on the other side where you're trying to increase customer engagement, and through that engagement cycle increase your revenues, right? So this was a trend analysis that was done by that same survey, McKinsey, and here some interesting trends again emerge. share of companies in which 50% of business functions report increase in revenue due to AI is growing. So again, that's a pretty good sign that the revenue piece seems to be the one which is latching on with companies. On the other hand, cost decreases are definitely becoming less common in most functions. By the way, this is a breakdown by functions, right? So you can see marketing and sales, product and service development, and so on. So, and they're trying to essentially capture where the decreases and increases are in each of those functions through this survey. And then there are some other interesting trends, like largest revenue increases happen to be in inventory optimization, pricing and promotion, customer service analytics and sales. Just cost decreases happen to be in talent management, contact center automation, and warehouse automation. So some pretty interesting numbers. It's always good to kind of start with some baseline about where the overall industry is at. Here's another perspective. AI research and venture capital, like what is going on in that world when we look at the broader AI ML landscape. So I have two data points here on the left. We have essentially paper submissions at NeurIPS 2019. As most of you know, it's like the premier AI machine learning conference. Not surprising, Google, Stanford, actually, here I am giving a talk at Stanford. But Google, Stanford, CMU, MIT, Microsoft Research, pretty much the top in terms of number of submissions. I think these are accepted, perhaps, or not sure about that yet. But I think the interesting trend here is that even from China, you see Tsinghua and Peking University, really kind of standing out now. They're literally in the top 10 or top 15. Also, some healthy contribution coming out of Europe. INRIA, ETH, EPFL, and I also see Cornell there, which is my alma mater. So good to see that there as well. And in general, there's been an exponential growth in paper submissions year on year. So while this is just the 2019 numbers, actually, if you go back and look at the number of submissions per year, it's been really growing exponentially as well, which just suggests that this is becoming a very, very sought after research area, AI machine learning. What I mean by that. Finally, within the NeurIPS itself, like there was I would say a lot of focus on NLP and biological sciences, from the research community. NLP, with the advent of BERT in particular, and BERT-like, all the BERT and BERT-like models, there's definitely been an explosion in terms of the papers coming out, the startups which are trying to build products based out of these BERT-like models and so on. So there's a lot of focus there. And biological sciences, naturally so, because of the pandemic we're going through. So there's lots of interest in drug discovery and epidemiology and so on. So lots of interest in kind of leveraging the latest and greatest that AI has to offer in those two fields. On the right, you'll see here is basically a trend for the total capital raised, starting back from 2010 all the way to 2020. And this reflects the amount of venture funding going into AI first companies. So these are companies whose business models are fundamentally kind of based on AI. It's a core piece of how they do their business. And as you can see, again, up till 2017, it was kind of growing at a certain rate. And then 2018, 2019, it's really taken off. That even the 2020 number, it's not really a dip. It was just measured in August. So, if you actually project the numbers out to the end of 2020, it's probably going to be on par with 2019. And that probably stayed flat because of COVID. Like probably there was not a lot of activity going on. The other interesting underlying trend is that rounds of over 100 million consistently accounted for about 10% of all funding rounds from 2018. So this actually suggests that it's not just that AI first are kind of getting those early seed rounds, but even further along, as these companies are growing and maturing, we are actually seeing that there's basically the chance of success is actually is steadying, right? Like, so you're seeing a steadying of the business model, right? That there is basically it's viable, right? So very, very interesting trends for sure. And it's definitely something that's worth I guess keeping an eye out on. Now I'm going to dive into the kind of second section of my talk, which is kind of going to be more on which AI machine learning trends are relevant to PayPal. Here we're going to slightly switch from very high level, like kind of business focused trends to more technical subjects. I will also touch upon why we think some of these trends are relevant to PayPal. In terms of the flow from here on, what I'm going to do is I'm going to kind of go over the trends that, again, as I said, I think are most relevant to PayPal and PayPal's business over the next 2-3 years. So what I plan to do is I'll just review a trend, talk briefly about why we think it's important to PayPal, also talk a little bit about what is the kind of industry landscape, what are other players in the space kind of doing in these areas, and hopefully it will give you a very broad but clear understanding of the primary areas of research focus, right? So I'll start with this this very high level overview. So essentially the innovation and disruption is happening across the entire ecosystem, right? So when we think about AI, Janice was, as she showed in her slide, we have essentially a hardware compute layer, we have the algorithms layer, then we have the applications. These are where all the users on our platform are interacting with us, be it through an app or through some kind of a service or a portal that we provide a merchant. All of these things we consider them as applications. And then finally, there is the tools and frameworks which kind of binds all of this together. So in each of these areas, we see there's innovation, and we are trying to figure out what's the best way to bring these innovative things into PayPal, right? So what is fueling this innovation? Well, part of it is just the slide I showed before. It's just fundamental AI research coming out of academia, and Google, Facebook, and their research labs. Of course, also venture funding plays a big role. They're actually creating a lot of new disruptive business models, which basically enable AI, innovation in general. So as I said, I will now, from this next slide on, start to talk briefly about the trends. I see I have only 6 minutes, so I have to move a little bit faster. So the first one, so this trend is what we call, client device AI, or broadly speaking, federated learning. This is an area where we, the whole idea here is we want to offload training and inferencing compute to edge and client devices, right? So the picture that Janice showed, where we collect all this data and then we move it to a data center, and then we do all this training, in our on-prem, data center, and then eventually we build a model and then we deploy it on the device. Or sorry, we deploy it in our data center again in a kind of real-time inferencing, or maybe in a batch inferencing environment. But we are trying to think of this new paradigm, in which the whole training and inferencing is going to happen on the device, which could be a phone, it could be a desktop. And again, this was pioneered by Google back in 2017. There's a very famous paper by McMahon on this. This was even used in their Gboard application. So we think this is the right time to bring something like this into PayPal. We are kind of at that right scale where we could really benefit by adopting this trend. It could really help our cost. It could reduce cost of model deployment and development. The other thing, it could also enable privacy by design. So as most of privacy is becoming a very important topic these days, and PayPal, we really want to be kind of at the forefront in making sure we put our users and our customers first, and we respect their choices, and enable essentially anything that our customers want, right, when it comes to privacy. So we believe that by this approach, we will be able to essentially make sure that essentially no data leaves a user's phone, right? And of course, this is also enabled by chip silicon vendors like Apple, Qualcomm. They have now, the amount of AI hardware that you can have on a simple smartphone is growing year over year, and there is a lot of compute horsepower now available on these devices. Second trend, this is about kind of just we want to be very judicious with how we use data and models. and it's primarily how do we represent the data and the model parameters, right? Make sure we represent them at the lowest possible resolution. This will, so for example, right, like if it's a floating point number, you can represent it with 32 bits today, that's the norm, but do you really need those 32 bits? Can you represent it with 16 bits, 8 bits? Is that sufficient? Right, so there's a lot of research going on, by Google, Facebook, NVIDIA, actually in this area. We are definitely also researching on our own, and we also anticipate this to kind of really help with kind of cost reductions, as well as being able to train models faster, and even like make the deployment, like especially in kind of real-time constrained environments, even the deployment, the SLA can be much lower. So this would be an initiative or a research initiative which is relevant for all domains, and it really this is a point where I think we need to start investing, or we are already investing in this area at PayPal. But this is one of those things that is super critical. A couple of other ones, I'll quickly touch upon them. I see we are kind of going to be short on time a little bit. This is around AI/ML hardware acceleration, via specialized hardware. So this is basically a trend where, today kind of GPUs are the workhorse for anything deep learning. But there is obviously a lot of activity in this space. Companies like Google, Amazon have built their own training and inferencing hardware. If you've heard of TPUs and Inferentia, these are some of the chips that have been built by these companies, primarily for deep learning training and inferencing. There's also a huge startup ecosystem. Companies like Graphcore, Habana are really like making custom silicon to kind of accelerate AI machine learning hardware, both inferencing and training. So we are also doing our own work in this area. And the primary impact of this will be, again, the same, like reducing cost and increasing the speed of model development and deployment, right? Finally, last, but of most interest to this audience, we are also doing some research, early research in quantum computing. We are trying to, do a POC where we are able to try to at least explore and see if quantum computing really has any quantum advantage over classical computing. We have several interesting use cases that we are kind of exploring here. Moving on to the second area, this is algorithms. So in the algorithm space, what we see are this is the trend that seems to be most relevant to us. No matter where we go, we see representation learning becoming like the thing to do. It goes across domains like deep learning or graph learning, natural language processing, everywhere. The core idea now is kind of learning representations and embeddings of words, of entities, directly through the data. This is a very I think I would say relatively recent trend. In the last 1 or 2 years, it really seems to have kicked up big time. And Janice mentioned, right, I think fraud is a very mature domain for us, right? So we are actually working against an active adversary here, right? Like fraudsters are continuously trying to break through our models. We are continuously trying to be ahead of them. So we need kind of these advanced techniques to be able to kind of catch up and actually beat them at their own game. This is I have to leave it at this high level. I'm happy to get into details, with folks later. There's a lot of this is the primary focus area of AI research, if you ask me. Across the board, this is pretty much the thing right now. A couple of other things I'll talk about real quick. By the way, Karen, please, if I know I'm already over time, maybe I should just stop on this slide. I can share the slides later. I want to be respectful of everybody's time.
I appreciate that. In that I know some of the students do have to leave. Maybe if you want to just do a wrap up on this slide, and then if they want to follow up with you, we can. If maybe Janice, if you want to put your emails, both of yours in the chat, they could follow up that way, or we could share it later on. That's fine.
Sure. So there is kind of, the two things I'll highlight on this page are really reinforcement learning and causal machine learning. Although these both reinforcement learning and causal machine learning have a long history of research, like they go back all the way to 1980s and even earlier probably. But from our standpoint, we are kind of at that, we feel like we are now at a point where there are use cases emerging where it's at the right sweet spot where we feel like there could be a really interesting benefit that we could get out of both of these so-called old techniques. With reinforcement learning, we think for recommendations it could be a very interesting area. We see that, for example, Netflix has started using RL in recommendations in their recommendation engines. Causal machine learning is the other interesting one, where a lot of machine learning we see today is around fundamentally based on the concept of correlation between a tag and a set of features that you have for those tags. But causal is kind of that new area of machine learning where essentially you try to do counterfactual analysis, right? You don't just stop at, okay, this is the correlation, but you're more interested in, okay, if I intervene in a particular way in this particular experiment, what is going to be the outcome, and how is the outcome going to be different if I intervene in a version A versus in a version B. And this kind of analysis happens all the time in marketing. We see these kinds of use cases all the time. So we are really kind of starting to invest in this area. And in fact, Karen, you may know this, right? But this is exactly the Stanford ICME engagement that we have ongoing with ICME right now. So one of the PayPal scholars, meaning the Stanford student, is a PayPal scholar. We are actually working on a POC with you in this area. Again, as I said, this is a very I think it's a very promising area. We think a lot of AI research, like Yoshua Bengio, Julia Paul, they all think this is the next big thing. And we also see a lot of open source development happening in this area as well. So I'll stop there. And again, sorry, I think maybe I just underestimated the amount of time I had. But yeah, I'll stop here. And again, we can share the slides later or something,
Sure,
so that people can take a look.
that would be wonderful. And thank you both so much for coming to the class today. So much information packed in 1 hour. So I really appreciate all of that. And then we'll share this if you want to send me the slides, and we'll also share the video with the students afterwards.
Yep, sure.
So, okay, thanks everyone.
Thanks, Karen. Thanks for having us.
Thank you very much.
Yeah, thanks for having us. It was great.
Bye now.
Yeah, bye.
Thank you. Bye.